Hello everyone and welcome to this video on general purpose registers of 8086 microprocessor. This is a topic under the subject U18EC506 microprocessor and microcontroller for the students of 5th semester EC students. Let me start over here. In the previous video we have discussed on the architecture of 8086. So we will be discussing today first of all what are the general purpose registers, and in continuation to that one we'll be discussing on what are the general data registers, as well as we'll be discussing on pointer and index register. So first we'll discuss on what is the register organization and how the register organization is being developed in your 8086 microprocessor. 8086 microprocessor, to summarize the summation of 8086 microprocessor is a 16-bit microprocessor which has 16-bit address bus, 20-bit data, 16-bit data bus and 20-bit address bus, and it has a number of powerful registers. Out of this one, we are having 4 general purpose registers. You will be having 4 general purpose registers as a 16-bit registers, or we can make them as a 8-bit registers also. How we will follow, we will discuss in this video. Out of the register organization, the register organization is been classified into basically 4 categories of registers. First one is general data registers, segment registers, pointer and index register, and one flag register. So coming to the first one, general purpose register or general data register. Here, general indicates they can be used for any different. Either it can be used for addressing, or it can be used for storing the data values, or whatever it is. So 8086 microprocessor, you can utilize these registers in programming to store the data or to give the address of one particular memory location. There are 4 general purpose registers, namely AX, BX, CX, and DX. These 4 registers are 16-bit registers. So these registers can be either used as a 16-bit registers or 8-bit registers. So when you are using as an 8-bit registers, so you won't take it as AX, but we'll name it as either AH or AL. So AX register would be split into 2 parts, into 2 8-bit parts. When you are taking it as 8-bit, either you need to take the name as AL or AH. Similarly, BX register has to be taken as BH and BL. CX register to be taken as CH or CL and CH. DX register, DH and DL. These are the 8-bit registers. Either you can make it an 8-bit or 16-bit. So you can use as an individual 8 bits, or you can make use in a combination of 2 8 bits or 2 16 bits. It's not compulsory that all should be used as a 16-bit or all should be used as an 8-bit. You can make a combination of this one. So these are the registers, and as we know in the architecture, we have seen in the architecture, these general purpose registers and the pointer registers and index register, this belongs to the execution unit part of your architecture. There, the execution unit part. So here, coming to the first one register, AX register. AX register is a 16-bit register which can be used as a 16-bit accumulator. It is also said to be an AL, or it can be used as AH and AL, where AL is an 8-bit accumulator. So BX is a base register, CX is an count register, DX is a data register. These are the names given to this AX, BX, CX, CX. And SP is nothing but the stack pointer, BP is the base pointer, And next one is source index. SI is the source index. DI is the destination index. These all the registers. Out of this one, 4 are general purpose, and these are pointer registers and indexes. Coming to these 4 registers, what are their specific use and how they are used in your programming? What are that one? AX is one of the key register in used in most of the instructions, as it is an accumulated register. So most frequently, the result of 2 operations would be stored in the AX register. And AX is a 16-bit accumulator, and here when you go for the 8-bit accumulator, it is nothing but AL, not AH. It is AL. Remember that one. So similarly, you know that BX can be divided into 2 registers, BL and BH. Similarly, CX can be divided into CL and CH. DX can be divided into DX and DH. Sorry, DL and DH. These are the registers for all this. So accumulator is one of the register, like when you go for multiplication of 2 8-bit numbers. The result of this multiplication is stored directly in the accumulator. If you want to use an instruction which is there in your CB, CWD or CBW, CBW, this instruction will directly take into consideration of AL register, convert it into byte to word, and it will be stored in your AX. Like that way, different instructions are there which will directly specify to accumulator whether you are giving the destination or source in the instruction or not. It will take it up directly from the accumulator. Similarly, when you want to go for base register, usually this BX register is used for indexing register, and when you are going for lookup tables, in your 8086 microprocessor, you can go for lookup tables. So when you go for lookup tables, you can use this BX register. And next one is CX register. CX register is the counter or the count register. Why this is specified as a count register is that whenever you are going for loop is nothing but if you want to repeat a set of instructions, if you want to repeat some set of instructions, some set of instructions to be repeated in the program, we usually make use of loop. Loop, what it does, it goes back to the destination where it again it starts with. So loop will, what it does is that the loop will refer to the CX register only. And every time when a loop is being executed, the CX value would be decremented by 1, and it will check whether CX is equal to 0 or not. If CX is not equal to 0, again the loop would be repeated. Not only for the loops, when you go for the string instructions and other instructions, this CX register is being used. There is one more jump instruction which is referring to the CX register, JCXZ. Okay. These are like this way. CX usually refers to the counter register. Once we go for the instruction set in detail, we'll some more clarity about this CX register. What's the importance of it. Similarly, DX register is a data register. It is used for general purpose data operations. In addition to that one, there is one more important of DX register. When you are going for IO port addressing, IO port means when you are going for any peripheral to be connected, what we'll do is that we'll make use of this DX register. DX register will hold the address of the port. To store the address, when you are going for variable port addressing, we'll store the address into the DX register. So AX is the accumulator, BX is the base register, CX is the counter register, DX is the data register. Any additional operations of DX is nothing but storing the variable port addresses. So these are all the general purpose registers. We'll have a small look at about the pointer and index registers, and we'll close this one. So when you go for the pointer register, there are 2 pointer registers. So in your 8086 microprocessor, we will be having one stack segment. To define a pointer in the stack segment, we will be having a stack pointer. We will get to know about the pointer and how to get the address over there in when you're calculating the physical addresses. So stack pointer is a pointer in your stack segment. Base pointer is a pointer in your data segment, or we can say store the offset values in your data segment. Instruction pointer IP is a pointer in your port segment. These are the two. And next one in the programming, when you are going for variable addressing, when you are having a source and destination to be separated, if you want to look at program very good, we can make use of these index registers, providing the addresses in the index register and storing the variable addressing if you are going for, or if you want to go for increment the memory locations and all those one. We will be making use of this index register and destination index and source index. And one more thing is that when you go for the string instructions, SI will be used for data segment and DI is used for the extra segment. These are the segment registers, general purpose registers, pointer registers, and index registers. I hope you have understood about the register organization of 086 and as well as general purpose registers and pointer and index register. In the next video, we'll discuss on the registers and segment registers as well as um, segment register and flag register. Thank you for watching this video.